Hello and welcome back to the solution videos for the Marquette ACM UPE Programming Competition held on April 19th, 2017. We're on question 5 now, which is about number bases. So this question asks students to write a function which takes in some number in decimal and a base and convert the number to that base and then output it as a list of characters. So a little bit of background. We work in base 10 normally when we talk about numbers, meaning that each of the place values of our number are powers of 10. So we have the ones place, the tens place, the hundreds place, the thousands place. Those are all powers of 10. 10 to the 0, 10 to the first, 10 to the second. There are other bases, however. So we talk about binary a lot in computer science, which is base 2. So that's just replacing all the 10s in those powers with 2s. So we start off with a 1's place, and then a 2's place, and then a 2 times 2 is 4's place, and an 8's place, a 16's place, etc., etc. So we can express numbers in 1s and 0s, and they still mean the same thing as some other number expressed in some other base. So the way that you can calculate these numbers is just by taking the digits and multiplying it by the place values. So you take 0 times 1 to get the 1's place value, and then 1 times 2 plus 0 times 4 plus 1 times 8, etc. And that's how you get to this 234 example right here. So for our function, we're going to be outputting a character array, because if we ever go over 10, we don't really have digits for that. Like, we've only ever needed 10 digits, so we never came up with like an 11th digit. So computer scientists use letters starting at A after they go over the digit 9. So the digit 10 is represented as A, and 11 is represented as B. So later on, I think one of these examples is base 16, and so you can see that E and A are 2 digits in that number, even though that they're letters. All right, so let's get into writing this. We're going to be writing in this skeleton right here, so let's get right to it. All right, so we'll start up. We know that our target number is going to be no more than 8 characters. So we've got this 8-character array initialized for us already. Now the algorithm for going backwards, going from this number in base 10 to the target base, is fairly straightforward. So let's go over an example to see how it works. So let's say that we're converting 100 from base 10 into base 3. So base 3 is these place values. So 3 to the 0 power is 1, 3 to the first power is 3, 3 squared is 9, 3 to the third power is 27, etc., etc. And we'll only need up to 243, but our program is going to do all 8 digits and just tack some zeros onto the end. So the way that we convert this is to go through all of these digits backwards, so from highest digit to lowest digit first. And you attempt to fit as many of that digit in to the number as you can. So for example, when we start with 243, we can't fit any 243s into 100 because 243 is bigger than 100. So we put a 0 at that position, and then the 100 over here stays the same. When we move to 81, however, we can fit a single 81 into 100. So we're going to put a 1 digit in that 81 spot, and then we decrease our 100 by 81. So we're left with a running total of 19 left with which to fill the rest of the digits. All right, so keep going. 27, we can't fit any 27s into 19, so we get a 0. 9, we can fit 2 9s into 19. So we decrease it by 2 times 9 is 18, and we get a running total of 1, and we put the 2's digit there. And then 3, we can't fit any 3's into our running total of 1, so we put a 0. And then finally, we have a single 1 left to put into our 1. So there we have it. Our base 3 representation of decimal 100 is 000-10201, because we'll have some zeros running on the front end of this as well. All right, so let's see if we can express that in code. All right, so we're going to be going backwards along the digits, and we know that we have exactly 8 digits. So our largest digit is going to be at the end of the array. So that would be 7. Or sorry, this is the power. So we're going from the largest power down to 0. And then we'll put them into the correct spots in the array inside this method. So we're looping from whatever our base is to the 7th down to whatever our base is to the 0th power. Just like we did in our example over here. We went from 3 to the 7th, though not really since we knew that would be all zeros, down to 3 to the 0th power, which is 1. So for each of these, we need to calculate how many we have of that digit that can fit into our running total. And our running total will keep stored in num. We don't have any need for the original value, so we can just use this num variable and change it. So our current digit then, to find out how many of something we can fit into another number, we just divide. We'll take our number that we're trying to fit into, divided by this usually smaller number that we're trying to fit into it. In this case, this can be our base to the power of the current power that we're at. So that would be I. And we just divide. And then we need to cast this to an integer since we started with a long, which is for our num. So this will give us the digit at this current power place. So then we need to decrease from our running total the total value of that digit. So we take the digit that we had and multiply it by that power. So that's equivalent to when we say we're going from the 19 here to the 1, we decrease by 2 times 9. We decrease by 18 when we went down here because this 2 is taking up that much of the value of this number. And then finally we need to actually store this digit now into the array. If we think about this a little bit, when we're printing out the array, the leftmost digit will be the one in index 0, and we want the leftmost digit to be the highest place value. So that means that when we're on power 7, the highest place value, we want to be at index 0, so that the highest one is all the way on the left. So we're actually going to be doing this a little bit backwards. So if we want it to be at power 0, then we need to subtract subtract it from 7. That way when we get down to power 0, it's in the 7th position, all the way on the right-hand side of the array. Now we'll go into our array for the output. And then finally, we need to actually get the symbols. So remember, we have some special symbols. We have some letters if we go up to base 16. And I believe base 16 is the maximum base that we are asking everyone to do. Yep. So we need to be able to get A through F for 10 through 16. The easiest way to do this is just have a char array that you index into. We'll call it symbols. So the 0th index of symbols will be the character that represents the digit 0. So the 10th element of symbols, the element at index 10, will then be A. So we can just index directly into symbols as like a way to get back out the correct character for that. So for 0, we'll get 0, 1 will get 1, 2 will get 2, all the way up the list. And then once we get past 9, for the 10th, or for the 10 digit, it's going to be A, 11 is B, 12 is C, 13 is D, 14 is E, and 15 is F. We don't need to go up to 16. You only ever have digits that are less than your base. So base 10 has 0 through 9, not 0 through 10. So F represents our 15, so we're up to the place that we need to be. So our digit is going to be indexed into symbols with the integer digit that we actually want. All right, and then we just need to return the array at the end, and we're good. So let's try that out. Let's use our example that we were running with over here. So we're converting base 3 of 100, sorry, base 10 of 100 to base 3. So let's say 10 test cases, and we're converting 100 into base 3. And there we go. We get our 0, 0, 0, 1, 0, 2, 0, 1. Awesome. We can run some of the test cases that we had over here as well. So we have 234 in base 2, 16, and 8 is what we want. Let's try some of those. So 234 in base 2. Yep, 111, 01, 01, 0. Perfect. And then 234 in base 16. So hopefully our letters are working. Yep, we get EA. That's it. And then we should get 352 for base 8. And there we have it. That's how you do problem 5.